says part B. It's asking the horizontal component of the baseball's velocity at each of these two times. So it wants us to answer what's velocity x here and what's velocity x here. Well, it's a trick question. You're thinking you're going to have to do twice the work, but we know that there's only acceleration in the vertical direction because of gravity, and there's no forces on this ball because there's no points of contact for this ball anywhere in the air. The only point of contact was by the baseball. So there's not going to be any acceleration in the horizontal direction. So that makes the velocity a constant in the horizontal direction. So we only need to calculate the horizontal velocity once, and that's going to be consistent over the entire arc of the ball. Similarly to the vertical velocity, the horizontal velocity represents the adjacent side given this angle. The hypotenuse is 30 meters a second, the ball's original velocity, and that can be broken up into a vertical and horizontal direction. The horizontal is the adjacent side, so I'm going to use cos. Cos of 36 degrees is equal to the horizontal velocity. The hypotenuse again is 30 meters per second, and I can solve it similarly to the vertical. 30 meters per second times cos of 36 degrees. All right, you will have different numbers for that, but that will be the velocity coming off the bat horizontally. That's the velocity here, here, and even when it strikes the ground. The horizontal velocity is a constant. Part B. Part C, calculate the vertical component of the baseball's velocity at each of the two times you found in Part A. Well, we know time 1 and time 2, they were calculated in Part A. And now the question is, what's the vertical velocity? Well, at time 1, the ball's going to still be going up. Certainly much slower than it started out, because on the way up, acceleration is slowing the ball down. And on the way down, the velocity will be identical, just in opposite directions. So we're only going to have to calculate this once. This is Vy on the way up, this is negative Vy on the way down. So the real question is, what's the velocity here at time 1? This is a velocity question, not a position. We can use this rather simple equation. We're now in part C. Wait a minute, somebody's at the door. Yep, I'm doing a tutorial right now, so just wait a second. You guys can wait inside, but okay, just don't make a lot of noise. V final is equal to V initial plus velocity, acceleration in time. So your final velocity is equal to your initial velocity plus how you accelerate through time. The final velocity is what we're trying to calculate, and let's just remind ourselves that it's in the y direction. Our initial velocity we've calculated here, so that's our initial velocity in the y direction. We know that already. Our acceleration is negative g, and our time is from t1 to 0 is delta t is just t1, which you've already calculated. Punch that in, and you'll be able to calculate this velocity. And over here at time t2, it's the same velocity in the negative direction. You'll still have a positive velocity here on the way up. On the way down, it will be negative. Same magnitude.